predict the house value. But problem is this, whenever we are predicting with the help of deep learning, by considering some data, we want that our prediction should be accurate. Okay? For this purpose, of course, there is some reference value. For example, I am buying this pen for 100 rupee. I bought it from market and its original price, okay, tag value, but I am showing to you and I am asking, please predict its price. Guess it. Okay, you will utilize your mind. You already bought too many pens from the market. You are also familiar with this digital board. Okay, many things you will calculate and you will guess it. It can be, might be 100, might be okay 150, might be okay like so. It's actual. This one is the actual value. Tag value is 100. You predicted, your hypothesis said it's 110. Yes, please.
So if we predicted lower value from the reference point, so where can it cause problems? How?
I'll explain it. Okay, in detail. Sure, I will. This is the technical point. Okay, very good point. But first, I would like to. So here, the main thing is some kind of an error, and where the error is this one minus y, and error is what? 10. Okay. According to your question, yes, you can also think y minus, in this case, lower value. Adil, you can notice. Here in this case, bigger value can be considered. Here in this case, lower value can be considered. Yes. Technically, you can consider either the bigger or either the lower value. But for this case, what you need to do, you need to consider the norm. Now I told you in start that you go from A to B or B to A plus minus, it will not affect the system. So you will say that this one minus y, or with the help of, okay, for example, we are covering from one point, some distance from initial to final. So by Pythagoras theorem, we are considering this one, okay, square value, shortest distance. So error. So it does not matter you are considering the lower or the bigger one. But simplicity case, we are okay. Simple. Consider the bigger one. Hypothesis. It will easy, but you can take the norm. Is it okay? Clear? All of you, please. Any question? So this norm, or you can say this error, is known as, in regression terms, is known as least square regression. I hope it is clear.
Yes, sir.
Thank you. So this difference, or you can say this error, least square error term, is telling you what? Okay, very important thing. Without error is 10, but with square, of course, it will give you some exponential growth or some exponential, okay, less value. It is also playing some beautiful effects. I will explain it later. But this least square error terms is known as what? It's known as cost function. Usually it is represented with this, okay, and of course 2 parameters involved in this, weight and the features. And this is the cost function, and of course once you are talking about this, then your equation becomes this. This is the least square regression. It's a beautiful fact. And here, very technical notice that what you do, you need to minimize this cost function, basically this error, so that if it will become minimum, then what will happen? Your guess, your prediction will accurate. Okay? For this minimization, you need to apply the gradient descent approach. Gradient descent approach will tell you that you are taking the gradient of this. Of course, you can decrease the error, or you can say difference derivative with respect to theta, weight value, as we don't need to bother the feature here. Feature, for example, pen is for writing purpose. We cannot change its feature. Of course, it's for writing purpose. Okay. House is for living. Of course, house is not a garage, not a shop. Okay. Feature. We are talking about feature, so we are not going to change the feature, but we are considering. We are yes.
Values.
Yes, value can be increased or decreased. Okay, so we will apply this, and this is known as, you can say, least square with some technical words, withdraw, half, learning rule. Just is the name, okay? If you cannot understand, leave it. Just it is the name. Okay, until here, how many things are not clear? Okay, let me make it more simple. And for example, if you house price reduction, it is kind of a revision what we did a moment ago. So there are certain things: house, size, feet square, number of bedroom, number of floor. Okay, I think it's enough, and price. Why? Price. This is the, you can say, exact price, but you don't know about this. This is just can be used for reference purpose. Okay. Here, house, of course, if we are talking about some house, this is some. Now, of course, 1, 1, 1, 1. Consider the 4 example. 4 houses. Of course, each of 1 unit. And suppose the first one, okay, so this is all, of course, first feature, second, third, 4. Here, of course, if you are talking about the example, 1, okay, so it will then become 1. So second example, third example, fourth example. we are talking about the 4 house. Okay, so the size of the first house second house, third one, fourth one. These are the sizes of the house in square feet. Number of bedroom of the house, you can consider on random basis. It can be any. Floor, okay, single floor, double, or you can say single. Price, you can say 100,000 rupee. The first one you can say 460, second one 232, third one 315, fourth one 178. There are well sizes, okay, number of bedrooms, floor single, so price is less. So technically facts and figures are there in front of you.
Sir,
Yes, please.
x2, x3 and x4 is
Yeah, this is important if you did not understand it. I, J. I represent
unit house.
no. Example, okay, of the houses you visited. First house you visit, you are talking about the first examples. How many examples of the houses are there?
4.
4. So I will represent
1, 2,
4. Okay, yes please.
Sir, here size is x1 and bedroom is x3. Where is x2, sir? x2 is missing, I think.
Sorry, where?
Sir, size, bedroom and floor.
bedroom.
Size.
You are representing with x1, x3 and x4.
x2.
This
Okay,
is x2.
this one, is it fine now?
Yes, sir.
Okay, thank you so much. Yes. Total 4 things
Sir,
are
here
there.
we are considering price as a feature.
Price is not a feature.
Then, sir, x4,
No X4, just consider
3.
X3.
3 value.
Okay, so consider here 3.
Okay.
Not, so, no, X is, this is the 4. I did not, please, okay?
This is 4, sir,
confuse-
because-
I'm so sorry.
Sir,
Examples of the houses. We are talking about how many houses?
4.
Four
houses. Okay, superscript is representing the number of houses
houses.
we visited. First house we visit, second house we visit, third house we visit, fourth house we visit. Features you can say here.
One,
That
two,
one will be features.
Okay, sir.
Okay, so this is the 4. Is it clear?
Yes, sir.
Yes.
So, if we are, for example, matrix is a very beautiful thing. Now it's become some kind of a matrix, and you want to know what is the, for example, what is x2, 3? This represent,
It means 2 houses and 3 features.
Second number house and
okay, we are talking about, this is equivalent to what value?
2.
Very good. Excellent. Why 2? Because we are talking about the second, this example,
And this features.
and its third feature. And third feature is
Floor.
2. Okay? So I don't want to be confused, but the things are very simple. Here, until here it is clear?
Yes, sir.
So very simple, okay? So for convenience, you can write x, Adil question, okay, here, x naught, x1, x2, x3, or you can say x4, or okay, suppose too many and generalized case. then its dimension, or you can say, if you here consider its equalize sign, if this is some, okay, no, represent some vector, and of course it belongs to real number space such that features are n dimension, okay, here n dimensions plus 1. Plus 1. Why I did not mention, why I write separate? One, it's kind of a constant, benchmark thing. Okay? It's not in a variation from, otherwise you can consider the index 0 to n, but here it is the benchmark. Once we are talking about the feature of the house, of course, it is representing the first one, representing the house itself, so it is not some kind of a unique feature. Though it's kind of, sorry, unique, but it's not kind of variable feature. Okay? Benchmark.
It is the minimum standard.
Yeah, minimum standard if you say some building to as a house.
There is something that is house.
That is a house. Okay, basic criteria fulfilled. Okay. Similarly, this in the okay, you can notice this is, we are talking about the subscript. Subscript. So this is the subscript. We are talking about the features. And if we are talking about some similarly weight parameter, of course, theta naught, theta 1, theta 2, theta n, so belong to here. This belongs to again n plus 1. The first one is representing some kind of a benchmark weight, intercept. Okay, from where you will start the construction or some can say value of a house. So this concept is giving you some kind of a hypothesis thing, or you can say some number of houses it is what? Basically it is a training set. Your computer, your program will get a training on it. It is known as a training set. And in this training set, of course, you will apply some learning algorithm. Learning algorithm, and in this learning algorithm you will get hypothesis H, hypothesis. Of course you will consider the example of different houses, and this example is a kind of a data, okay, and work as a training set for you, and by applying some learning algorithm you will predict regression, okay, least square error, least mean square error hypothesis H. And of course, if I write it like this, depending upon weight parameter for the features of various, okay, house. So this is basically hypothesis. And of course, this this hypothesis follow some variable which is following the living area, or you can say X. That's why it is known as a house. And it is predicting or estimating some price value. are giving you some kind of estimated
Value.
price Y, of course, for living unit. Living unit, or you can say house. This is the concept of hypothesis. And once you will submit in here this hypothesis by considering summation of all the possible features of the house, of course, this summation sign, and in this summation sign, you know that you are summing up all the features. So it will, index will go from some value 0. Why I am considering 0? Because you are summing up the living area. X0 will be included here. Go to the n value. Maximum number of the features. 0 is first living unit, then first number of area, bedroom, okay? So I'll go up to there. And of course, it is forming some kind of, for generalized case, you can write like this. And this is what I is index a moment ago. I have shown you people here, okay? I is representing here 0, 1, 2, n, or you can say belong to n plus 1. So, I already demonstrated that you can, these are the, each weight is a multiple of each feature. You can write it in the form of, or you can write it in this form. It does not transpose, flip, okay? Flip the vector values. It will not affect. So, by applying the least square, okay, error, you will get a term. And of course, this is for examples, examples. For example, a moment I did, I've shown, I portrayed the 4 houses data in front of you. So, for example, okay, even I don't need to mention the superscript, you should not worry, but this is just for the case. And it is giving us some kind of a cost function. And of course, this cost function sum up m. And if we are talking about the m example, then we need to divide all this with m data set. For example, we are talking about 100 houses, and of course, whatever the price is, it is a cumulative price, then sum up all the prices. But for getting one price, we need to, okay, among 100 houses, we need to get the price of 1 unit house. We need to divide this total prices with m, mean 100, then we will get 1.
Average price of.
Yeah, average prediction purpose, okay? 1. Then we will get the price of 1 unit house in terms of average kind of a thing. Prediction. Is it okay? And here we do some kind of a cosmetic surgery. This is the tricks of mathematicians who are playing in the field of deep learning. They will multiply this system with 2, 1 over 2. Do you know why? This 1 over 2, this 1 over 2 is not a big thing. This is just kind of a scalar value, but mathematician is doing it for easiness of the computation system, because once we are applying the gradient, okay, theta, then this 2, you know, if we are getting the derivative of x square, we will get what?
2x.
2x. To get rid of this 2, we
Cancel
need
this.
to use 1/2 so that we can get rid of this 2.
But in equations, we should apply it on both sides.
And this is the
We should
trick. That's why I said that this is not the. Once you know how to play with mathematics, then don't worry about it. Okay, I know that is you need to multiply both sides 1/2. But I said that this is the trick. Okay. Okay. If you don't want to, you can ignore this. Then you can consider this 2. But as I told you, otherwise, you should not consider the scale, only now. Okay? Are you getting my point?
But
If-
sir, in derivative,
Mhm.
descent gradient, some
Yeah.
problem.
Yeah, this is the word. It is telling you once we are applying some kind of a derivative, we want to predict the price value at an instant. Okay? In last lecture, I had demonstrated that instant. Okay, small precise. Okay, information can be obtained with the help of derivative. So I said that consider the least square error with the power of 2, and here m is fine. Okay, you got the concept of m, but this 2 is kind of a cosmetic surgery, or you can say that artificial thing here would be that we are multiplying this equation with 1/2 only on one side, not on the two side. This is the mathematician
Trick.
trick, or you can say that this is there. For example, you know, with 1,000 or you can say 10,000 rupee, you can travel from Rawalpindi to Karachi. But on safe side, you are considering 15,000. You know, 10,000 is sufficient for you. 5,000 for what? This is your mind, okay? Vision,
Like in this,
safety level.
like when we divide something, it reduces the price.
No, not reduced to the, but here we also consider the norm scale value.
Okay.
Okay?
So this square is also not part of the equation.
Yeah, I told you that. Okay, let me explain. Very good question. Thank you so much. Simply, one is our y is the actual price, and our hypothesis is h theta of x, and we want to know the error between two, or what we want to do. We want to make it, okay,
Precise.
minimum error is minimum, or we want to minimize the error, we want to minimize the difference, we want this thing that is almost near to 0. This thing or not? This thing? Yes. Yeah, we can simply do this. Yeah, we want this. Okay?
Prediction.
We want this.
Yes.
But we applied this scale, norms. Norms is your choice because you said that if we predict, we offer the lower value or we offer the higher value. Are you getting the point?
Yes.
Remember it? Thank you so much. So in this scenario, otherwise it's simple. It's simple case. Then you always you must consider the lower value in all case, or you must consider, it is also possible you can consider
Higher value.
higher value.
Both.
But you want to make a system autonomous, okay? Fully automatic, deep learning system. So you consider the norms, scale norms. Okay, and in my sum of lecture, I told you that norms, distance formulae, A to B, B to A, plus minus. Okay, got it?
It's clear now.
Oh, now this is the reason, my child, this is the reason we are considering this thing. Okay? Yeah, I got it. That we should multiply this both side for beautiful mathematics. but sometimes ugly mathematics also work. Okay? Yeah, we are human, supreme creators. Okay, we can think better than the things. Okay, system. So, because there is the reason, little flaw you can say in the artificial, that's why we say deep learning, artificial intelligence, machine learning cannot think like a human. Okay, there are loopholes. No system or deep learning work without this. This is the thing. Okay. So I hope until here it is clear, and if we get this value, then we know one thing in this all the system, two features are clear to us. We want to predict what is the intercept value, what is the weight value. The important thing is this, it's unknown to us. Okay, it's unknown to us. So we want to predict this.